Okay, guys, we're going to do things a little differently today. I'm going to take you through the notes using Edpuzzle. As we go through the notes, you'll notice that sometimes the video will stop and you'll be asked to answer a question or two. So make sure you're going through and doing that because you guys, I will be able to tell which ones you answered, how you guys did, so make sure you're going through that. So let's get started. Okay, it says since f of x equals to the x is a, well, this is a review of exponentials really quickly. Since it's a function, that means that it has an inverse function. So let's see if we can identify that real fast. If this is my function, I'm just going to rewrite it quickly as y equals 2 to the x. That's going to be my original. And if I wanted to find the inverse, I need to switch the x's and the y's, which means I would now have x equals 2 to the y. This is my inverse function. Well, normally what we would do next is we would solve for y. But here's the problem. How can we solve for the exponent? Well, that's where logs come into play. If you remember from last year, logs take this kind of gross thing. It says, well, I want to get the exponent by itself, and we created this thing called a log to allow us to do that. What a log is going to do is it's going to take that base, so it's going to become the base of my log, and then we're going to switch the exponent with this x so that the exponent is now by itself. So logs are the inverse functions of exponentials. A log is going to be defined by this statement here. So if I have an exponent that's y, a log will be equal to the y. And we read it like this. It's read as log base a of x. And this base a has to be greater than 0. We can't have a negative base. It also can't be 1 because if I raise 1, so if 1's my base, like 1 to the anything, so 1 to the 1, 1 to the 2, 1 to the 3, 1 to the 4, it's always going to equal 1, so it doesn't really make sense. So big thing is a, the base has to always be greater than 0 or and just not 1. So one thing that's worth noticing is when I have a log, the answer is the exponent when it's written in exponential form. So the answer to a logarithm is an exponent. And these are the two different ways that we write it. This is the logarithmic form, and if we want to rewrite this with y as the exponent, we write it in exponential form. So let's just start by seeing if we can rewrite things that are written in logarithmic form. So let's take a look. Remember, if we rewrite it, this 4 is the base, so it's still going to be 4. The answer to a log is an exponent, so this is going to become 4 squared equals 16. Well, that's a true statement. That looks familiar. This is good. Let's see if we can do number 3. If I were to rewrite this, my base is 9. So this is saying 9 to the 1/2 power is equal to 3. Well, we'll review in a second that the half power means square root, so the square root of 9 equals 3. If you're watching this on YouTube, go ahead and pause the video for a minute. If you're in Edpuzzle right now, the video is going to pause, and you guys are going to answer number 2 and number 4 for me. So do it on paper first, and then answer the questions. So let's move on. We just rewrote things into exponential form. Now we're going to write things that are in exponential and logarithmic form. So let's take a look at this. Remember, the base here is going to be the base of my log. So this is going to be log base 2, but my answer should now be the exponent. So log base 2 of 8 is equal to 3. Okay, well, let's rewrite number 6. My base is 10, so this will be log base 10. Remember, my answer should be the exponent. So of this is equal to -2. Go ahead, same thing if you're watching on YouTube, pause the video. If you're in Edpuzzle, some questions are going to pop up. You're going to do number 7 and number 8. So now that we can rewrite these things, let's see if we can actually evaluate some logs. A couple things to remember. Remember, the answer to a log is an exponent. So we're going to try to evaluate things. We want to rephrase it in our head to help us. So when I have log base a of b, I really want to be thinking a to the what power is going to give me b. So let's jump down here to number 9 real fast. I'm going to rewrite this quickly as 3 to what power equals 9 or is 9. So if I want to rewrite this really fast, I'm saying 3 to what power is 9? That's what this thing here is saying. Well, we know that 3 squared is 9, so to the second power is 9. That's my answer to this question. See if we can do number 10. Okay, this is saying 3 to what power is 27? Well, if I wanted to rewrite this, I'm saying 3 to what power is 27? Remember, the answer to a log is an exponent. Well, 3 cubed is 27. So the power of 3. Now in a second, we're going to see some things. It's good to remember, if I have a negative exponent, that's going to flip the fraction. So a good example of this would be if I have 4 to the, to a negative exponent. If I have 4 to the negative 1, that's going to just flip this upside down. I think it's a good thing to remember. So if we have an exponent that's a fraction, it's going to give me a root. So I gave an example here. If I have 4 to the 1/2, that's going to give me the square root of 4, which is 2. Another example might be like 8 to the 1/3. That's asking me for the cube root of 8. The cube root of 8 is 2. So when I have negative exponents, I'm flipping my fraction. When I have fractional exponents, that's going to be a root of some sort. Well, that's going to play in a moment. Let's flip this over now. Because you'll notice now I have this. So remember, I'm supposed to think 2 to what power is 1/2. Okay? So remember, if I wanted to, I could rewrite this. I'm saying 2 to the what power is 1/2. Well, that 2 got flipped upside down. What flips things upside down? A negative exponent. Specifically in this case, -1. -1 just flips. So go ahead and do number 12. Oopsies, the number 12 disappeared. Go ahead and do this next problem by yourself, and we'll resume in a second. So it turns out when we're dealing with logarithms, there's some special cases that we want to think about. The first one is that log base a of 1, so a could be anything, log base 2 of 1, log base 5 of 1, whatever, is always going to equal 0. Well, let's think about why. This is because a to the 0th power, let's think about that. A to the 0th power, well, anything to the 0th power is equal to 1, right? So whenever I have log base something of 1, the answer will always be 0 because you have to raise it to the 0th power to get an answer of 1. Well, here's another one. I have log base a of a equals 1. So this is because a to the, remember this is the exponent, to the first power, let's think about that. A to the first power, well, nothing's changing. A to the first power is just a. So a to the first power is a. That's why anything that has the same base, so log base a of a will always equal 1. So log base 3 of 3, log base 4 of 4 will always equal 1. Let's look at this. This is saying log base a of a to the x equals x. Let's see if this makes sense. So this is because a to the xth power, well, of course, a to the x power is going to equal a to the x. So whenever I have a base and then the base of this exponent is the same, the answer is just going to be x. Okay? Here's one more example. This one's kind of gross. Notice I have a to the log base a of x, it equals x. See if this makes sense. Because the base of this is a and the exponent is x, I could rewrite this whole thing as, this is an exponential right now. I have a to the exponent equals x. So I could rewrite this as log base a of the answer equals the exponent. Well, that's a true statement, and so that's why this works. So if I have a to the log base a of x, that equals x. If I went through this quickly and you need to take a minute to think about this, I would pause the video and just think through why these 4 statements make sense. If you have a question and you're in class right now, you can raise your hand. I'll be happy to come talk you through that a little bit. So let's see if we can evaluate some of these now. This is log base 6 of 1. Well, we just said when I have log base anything of 1, the answer is always going to be 0. That's because if I wanted to, I could rewrite this as 6 to the what power equals 1, 6 to the 0th power equals 1. Okay, Here I have log base 4 of 4 squared. Notice that my base and then my base and my exponent are the same. So the answer is going to be 2. We can think of this because it's saying 4 to the what power is equal to 4 squared. Well, that's going to have to be a 2. Okay. Go and pause for a minute. See if you guys can do number 14 and number 15. Okay, we got 2 more things to cover quickly. The first is this concept of a common logarithm. The logarithm with base 10 is called the common log, and it's denoted by omitting the base. So a lot of times whenever you see log of x, there's an invisible 10 there. It's base 10. And the inverse of this is going to be, because remember this is base 10, the inverse is going to be 10 to the x. And a reminder, when you're looking on your calculator, I'll actually pull one out real fast. Whenever you see the log button, so you'll notice there's my log button, that's actually going to be log base 10. So let's see if we can evaluate a couple things of log base 10 without using a calculator real fast. I'm going to start by rewriting this. Remember, there's a little 10 here, so this is saying 10 to the what power is equal to 10, because my answer is the exponent. Well, 10 to the first power is equal to 10. Okay, well, let's look at this now. This is saying 10, right, to the what power is equal to 0.001. Well, let's actually think about this real fast. 0.001, that's 1/1000th, right? So if it was 0.1, it'd be a tenth. 0.01 is a hundredth. 0.001 is a thousandth. So this is really saying a 10 to the what power is 1/1000. Well, remember, to flip it upside down, it has to be negative. So I already know that this is negative. I had to go from 10 to 1,000. This is 10 times 10 times 10. 10 cubed is 1,000. So my answer is -3. Okay. Let's look at this one. This is saying 10 to the what power is equal to the square root of 10. Well, we learned to take the square root. We have to have an exponent of 1/2. Then lastly, we have this one. It says, this is, remember, log base 10, so 10 to the what power is equal to -3. Well, that actually doesn't really make sense, does it? Because in order to get a negative value, this would have had to be negative to begin with. I would have had to have an odd root. This is actually something that's undefined. There's no value that will make this a true statement. We'll talk a little bit more about these weird undefined cases another time, but it's just good to get an idea of it. So whenever I have log base 10, remember my base always has to be, that a value always has to be positive, so it really doesn't make sense that I'm going to get an answer that's a negative for this. So, and again, we can talk about this another time. Okay, the last thing I want us to do together is to do some basic solving. We're going to start easy, and then we're going to get a little bit harder. We'll do these ones together. So now we just have an x involved. That's the only difference. So this is something we've already seen. If I rewrite this, this is saying 2 to the x power is equal to 32. Because remember, the answer to a log is the exponent. Well, 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32. That took 5 2s, so the answer is 5. Okay. So look at this one. This is saying 3 to the third power is equal to x. Well, that's really just 3 times 3 times 3, and we know that that's 27. Okay, well, now I have 4 to the second power equals x minus 2. Well, this really isn't too hard to deal with. 4 squared is just 16. I can add 2 to both sides. Well, that's going to give me x equals 18. Okay, go ahead and pause. See if you can do number 23. Give it a try. If you're on YouTube, go ahead and pause it. If you're in Edpuzzle, you should get a question. Okay, well, now that you've tried this yourself, let's see if we can do this. This is saying 2 to the 6th power is equal to 2x plus 10. Well, 2 to the 6th power, that's going to be 2 times 2, which is 4, 8, 16, 32, 64. I can subtract 10 on both sides. and then I can divide by 2. Okay? We'll solve more next class. We're going to actually review condensing and expanding as well. But that's a quick review of some basic log stuff that you need to know. You're going to go ahead and move on to your classwork now.